coral reefs and why are they important? Coral reefs are known as the rainforests of the ocean because they are ecosystems that support a collection of extremely diverse biological communities. They support a third of all marine life. While commonly mistaken for plants or rocks, corals themselves are animals within the phylum Cnidaria and class Anthozoa. The class Anthozoa has roots from Greek words anthos, meaning flower, and zoa, meaning animals. Thus, Anthozoa means flower animals, referring to their unique appearance and characteristic animation. The class Anthozoa includes corals and anemones, both of which are related to jellyfish. The coral community is extensive and relies on many factors, including stable temperature, pH, light and dark cycles of photosynthetic processes, water flow or current, salinity of the water, chemical composition of seawater, and trophic cascade. The biology of the reef is complex and vibrant. Coral communities sustain themselves through rapid, efficient cycling of nutrients and symbiotic relationships. The coral community extends far beyond the immediate reef. Let's take a look at the energy flow and food web of the coral community. Coral reefs are in shallow, clear water because they need energy from the sun. Although this clear water is devoid of nutrients, coral communities are extremely efficient at supporting themselves, as diverse as this type of ecosystem is. Energy from the sun travels through the water and reaches the photosynthetic producers of the reefs. Producers include plants, photosynthetic cyanobacteria, zooxanthellae, and bacteria. Consumers of the coral reef include both herbivorous organisms such as mollusks and echinoderms, and carnivorous organisms like fish and larger predators such as sharks. Throughout the reefs, bacteria decomposes wastes, which go back to the primary producers as nutrients later. Coral reefs rely on symbiotic relationships to sustain themselves. Coral reefs are supported by their symbiotic relationship with zooxanthellae. Zooxanthellae is a species of microscopic algae that are photosynthetic. They produce nutrients for the corals, and the corals in turn provide a protective environment and the necessary reactants for photosynthesis to occur. The process of photosynthesis supplies the coral with oxygen, which helps the coral to remove waste products from the reef, and carbohydrates, which are essential in building the coral's calcium carbonate exoskeleton. Almost all, or about 90%, of the algae's photosynthetic products go to the corals for incorporation into them. This is a delicate example of mutualism because if the zooxanthellae produce too much oxygen, it can be harmful to the corals and cause coral bleaching. Thus, corals must regulate the number of zooxanthellae and may expel some of the number of zooxanthellae if it becomes excessive. Primary production in coral reefs is relatively high. Primary production describes the amount of new organic material or biomass created by the primary producers in an ecosystem. Primary productivity, measured in grams of carbon produced per square meter of ocean surface per year, and estimates of total ocean productivity are between 75 and 150 grams of carbon per square meter per year. The autotrophs responsible for this production include phytoplankton, coralline algae, zooxanthellae, other algae, and various seaweeds. In conclusion, it cannot be overestimated how valuable coral reefs are to our oceans and to humans. Coral reefs provide shelter, nourishment, and a habitat for a third of oceanic life. The level of biodiversity and productivity of the coral community is a manifestation of its significance to all parts of life on Earth.
Until recently, deforestation was not considered to be detrimental to, or even something that affected, coral reefs. However, recent research has shown that deforestation and the ensuing soil erosion and land degradation has an increasing impact on coral reefs. The first and biggest example of this threat is on the biggest reef in the world, the Great Barrier Reef off the coast of Australia, spanning almost 133,000 square miles. It is suffering greatly due to the sediment runoff. Despite the fact that this is a relatively new discovery, without proper reactions, the consequences could be disastrous.
The National Oceanic and Atmospheric Administration has estimated that 500 million people around the world live within 100 kilometers from a coral reef and benefit from the protection it provides. But unfortunately, of the 109 countries that coral reefs are found in, significant reef degradation has occurred in 93. Today, 27% of the world's coral reefs have been destroyed beyond repair, and the majority of the remaining reefs are considered to be under a serious threat. This unfortunate pattern of coral reef destruction has been aided by ozone depletion, coral mining, coastal development, reckless tourists, water pollution, and harmful fishing practices. But sedimentation, ocean acidification, and climate change are the three factors we will focus on today. Sedimentation occurs when silt and soil from mining, logging, or farming falls into rivers and is eventually deposited into the ocean. When this sediment falls on coral reefs, it will suffocate the coral by depriving it of the light required to survive. Although sedimentation is a key contributor to the destruction of the coral reefs, it is far from the only threat. There is currently a higher atmospheric concentration of carbon dioxide than has ever been experienced in the past, and this heightened concentration has led to a phenomenon known as ocean acidification. As the ocean, which has absorbed roughly 525 billion tons of carbon dioxide from the atmosphere, has a higher and higher amount of carbon dioxide, the pH drops slightly. This affects the shell formation of marine organisms such as shellfish, marine plankton, and coral. Additionally, the increased amount of carbon dioxide being dissolved into the water has weakened coral skeletons, making them more likely to be eroded away with waves. A phenomenon known as coral bleaching occurs when algae known as zooxanthellae leaves coral, thereby depriving coral of its primary energy source and its color. Coral bleaching has been linked to climate change and increased water temperatures. Although it is not necessarily a permanent state, the environment surrounding recently bleached coral must return to normal temperatures immediately, or it is likely to die. The destruction of coral reefs poses a significant threat to the ecosystem as a whole, but what can be done to help?
Many people in the world today love venturing to tropical places such as the Caribbean and Australia, especially to see the beautiful coral reefs. However, tourism can be incredibly harmful and permanently damage the coral reefs. Dangerous direct impacts of tourism can be from popular tourist activities such as snorkeling, scuba diving, boating, fishing, and collecting. These activities cause physical breakage of the coral and kick up sediment. Motor boating and yachting can cause physical damage from anchoring and boat groundings. Many tourists often collect things such as shells, lobsters, conch, and coral, but this threatens local survival of rare species and contributes to overexploitation. Indirect impacts of tourism include things such as resort development, construction, and operation, as well as marina construction and operation. Sewage from tourist-related infrastructure ends up draining into the reefs, and construction and motorboating can also kick up sediment. It's hard to completely stop these negative impacts from happening because tourism is a crucial event to economies and employment. One example of countries that are trying their best to help out is attempted to be controlled by governments. On June 11, 1998, President Bill Clinton put an executive order to preserve and protect the biodiversity, health, heritage, and social and economic value of U.S. coral reefs, ecosystems, and the marine environment. The executive order entails all federal agencies to protect coral reef ecosystems to the best of their ability and directs certain agencies to develop coordinated, science-based plans to help rejuvenate damaged reefs in both the U.S. and the rest of the world. However, not all governments are as dedicated to improving the coral reefs. For example, in February of 2014, the Australian government approved a dump of dredged spoil on the Great Barrier Reef, which covers 3 million cubic meters. Although this area is not located in the actual protected marine park, it is still located in the World Heritage Area where undisturbed seabed is. This action will expand Abbott Point, making it one of the world's largest coal ports. The trading ports working alongside the Great Barrier Reef are responsible for the export of commodities worth $40 billion a year to the Australian economy. This is a common case of putting the economy before the environment. Some environmentalists have just lost hope and believe the coral reefs are doomed. They believe that coral reefs are going to the oblivion and will never improve unless action happens now. The media, as well as the government, sugarcoats the coral reef situations, and if this continues, no progress will occur. The damage is rapidly accelerating, and millions of people will be out of jobs and hungry, and ecosystems will also be ruined.
There are many organizations that tackle this issue, but two of the most accomplished are the United States Coral Reef Task Force and the World Wildlife Foundation. Both groups act on both large and small scales. They both lobby heavily for laws and restrictions that benefit coral reefs. They also are often responsible for physically taking care of the reefs, diving down to run tests, clean up the reefs, and clear sediment. With the work that the USCRTF and the WWF are doing, countries around the world are practicing techniques to protect and conserve coral reefs. The outlook for coral reefs is much brighter than it could have been without these excellent groups.
Due mainly to human negligence, the coral reefs are in danger and are slowly dying. Luckily, though, there are a few things that we can do to help restore the reefs and their fish. One way is to make sure that all of our sewage and waste is disposed of properly by constructing wastewater management plants. This will likely require government involvement through legislation, but will reduce any waste that is able to get into the ocean and cause harm to aquatic life. Another thing that the government could do is to establish protected areas with strict restrictions on fishing. While 6% of all land is protected in the form of conservation parks, less than 0.5% of all of the ocean is under some form of regulation. That is why regulating fishing as well as the trade of live reef fish will reduce stresses on the reef and get rid of any threats to reef fish. One thing that each individual can do is help to reduce the consumer demand on reef products. For example, all marine aquarists can reduce demand for endangered and exotic reef fish by buying more common and sustainable fish. Also, people can stop buying products such as shells, turtle eggs, or shark fin soup. Another solution is to reduce overall carbon emissions. Carbon dioxide and climate change are changing not only the temperature of the water but also the chemistry of the ocean. These changes can often cause coral bleaching, which makes reefs more susceptible to mortality. So anyone can turn off the lights, drive cars less, and maybe even use more blankets instead of heat. Reef Check Worldwide has posed a few different solutions. They wish to educate the public about the crisis in order to stimulate interest in the salvation effort. By doing this, they hope to accumulate a number of volunteers to form teams worldwide that monitor reef health. The nonprofit organization hopes to collaborate with both government and the private sector to help the reefs. Any individual that wants to help could make an effort to get educated about the subject and/or volunteer to help the cause. Using these posed solutions, please help to conserve and restore the reefs.